Okay, dear participants, this part of the course, short course, well, I'm going to uh, demonstrate how can use finer mesh. Where? Not, as I said at the beginning of the session of today, not entirely all the parts of the body, but only at the parts where we have a discontinuity. Okay, we have abrupt changing or we have empty space. Only in the vicinity of these parts use finer mesh, smaller finite elements, to be able to find the stress value more accurately. Okay, if we increase the number of elements, then well, the solution going to be more accurate. But since you are using an ordinary computer, it is not a supercomputer, well, it cannot use a much smaller finite element at all the points. If you're going to obey to the recommendation and determine the stress values, especially at the places where the maximum stress will be maximum or close to maximum value, yeah, be aware in Inventor there are two alternative methods. Well, find the slides of, for instance, yes. Well, there is a hole and it is, mathematically speaking, a discontinuity. Okay? Well, if we calculate the stress at the cross section where we have such an empty space, okay, we find the stress value, atomic bonding forces divided by the cross-sectional area. But when we solve the problem or tested it experimentally, we see that the stress value going to be greater than the calculated one. This phenomena has been perceived for the first time, how many years ago, by an engineering scientist. And well, such valuable graphs output, okay, for the interest of the designers. Well, K factor is defined. Well, the phenomena is known, called stress concentration. If there is an abrupt changing in the geometry, for instance, here you see cross-section abruptly decrease from here to there. If you do not use a fillet, it's an engineering solution. If you're keen on using a sharp edge between this and the other part of the body, then theoretically over there the stress will tend to go to infinity. Yes, it is true. From the outcome of that valuable studying, see, well, for instance, R over D ratio is along the x-axis. R is the filleting radius. Say that there is no fillet over there, but a sharp edge. Rounding radius is 0. K factor, how it is defined, maximum stress divided by average stress is the K factor. Well, average stress can be calculated at the cross-section. Well, the atomic bonding forces divided by cross-sectional area. But the result must be calculated by the K factor. Okay, if of course you have no Nasran, no Inventor, no fusion, okay, need to solve the problem on the paper. It was the case beforehand, case of the designers. Okay, multiply the calculated stress by K factor. K factor, how much it is? If the filleting radius were 0, then you see K factor is infinitely large. Asymptotically, you see this curve approaching to, say, unlimited K value. So from here you can also see that if the edge were a sharp edge, theoretically with 0 rounding radius, then over there the stress will tend to go to infinity. And there is no such a material to resist infinitely large stress values. So the engineering solution, don't forget to round the interior edge. While the rounding radius increases, you see K factor decreases. The other parameter it is effective is the ratio between the size of the cross sections, D over D ratio. If the discontinuity is just due to the existence of an empty space, then well, another k-factor graph we have. Well, here the dominant parameter is diameter of the drill divided by the dominant size of the solid part. 2r divided by d. Yes, the other thing to know, well, these graphs are independent of the material, whatever the material of the object is. For all the materials, these graphs are valid. Of course, material is not composite. Okay, it's a continuous media. Okay, for instance, steel, copper, brass, aluminum, etc. Continuous. Yeah, you know the main assumption in Newtonian mechanics. We assume the media as continuous media, continuum mechanics. We do not consider the empty spaces between nucleus and the electrons. You know, we say that it is completely solid. Newtonian mechanics. That mechanics still valid for the most of the engineering applications today as well. Okay, now say obey to the recommendation and in the vicinity of the discontinuities or abrupt changings, use finer mesh. Okay, in Inventor, yes, the alternative method, one of them, well, find this slide, local mesh control facility. Under the control, well, for instance, in the example, you see diameter changed, say, abruptly. Well, in the vicinity of this threshold part, transition part, use finer mesh. How? Using local mesh control tool of the software. The other technique, well, enable the software to use finer mesh. Not under your control, use refinement technique. And also, this is a facility, and also it is the answer of the question. Yeah, well, test it. For instance, use 700 elements, solve the problem, find the stress, and then increase the element number, 800. Stress won't be the same. It's going to be increased in the order of few megapascal even. Okay, increase the number of elements, run the problem again, then the stress value won't be the same. Okay, if you want to see the same value, well, you know the limit, unlimited elements, differential equations, analytical solution. But say, while we are increasing the mesh size, then the stress value may converge. Most of the cases converge to a value. And then the rest. Okay, increase the mesh size, decrease the mesh size, increase the number of elements, but the changing in the magnitude of the stress going to be negligible after a certain number of meshes. So we say that it is diverging. Okay. If you use this tool of the software, can sure that okay, the problem has been solved such that the selected for that last analysis, the number of elements are in the reasonable order. No need to increase the number of elements furtherly. Because if you increase the elements furtherly, then the changing in the number will be very little, negligible. Instead of finding the value 700 megapascal, 200 megapascal, it is going to be 200.01 megapascal. No need to have such an increment, because in engineering, you know, we have at the background factor of safety. It is 2, 3, 5, such a number. So do not deal with such little increments. So do not furtherly run the software via increasing the mesh size. Okay, if we use this tool of the software, mesh refinement facility of the software, then can sure that, yeah, the mesh size is in the reasonable order. And also in doing this inventor, in the vicinity of discontinuities, use finer mesh. Not the other parts, but only such parts inventor use finer mesh. It is going to be automatic. Well, to be able to allow the inventor, enable the inventor to use mesh refinement tool, clicked on this button in mesh panel, can find it, and then in the dialog box, write the maximum number of refinement. Well, in this example, it says that increase the number of elements, decrease the mesh size 5 times, step by step. And then, inventory at the background makes such a comparison. For instance, fourth analysis, fourth running, while the stress values were output. And then this fifth running, inventor again generate the stress values, output the stress values, and software at the background make a comparison whether the stress found at a certain point, the last running, is 10% greater than the result of the previous running. Well, of course, if the stop criteria here, C's value percentage written as 10%, to be able to output the results a little bit more accurately, then decrease the percentage. It is a stop criteria. It is like do loop, There should be stop criteria. We say that if the calculated value is 10% greater than the previous one, then stop. That is okay for us. If 10% is too much, then decrease, say 5%, 1%. The other one, age refinement factor, it is a little bit tricky. Well, open a parenthesis and explain what it is. In this example, it is 75, 0.75. It says, well, decrease the mesh size in repeating the calculation. It is like a loop. Decrease the mesh size at the places where the stress is in the maximum order or 75% or greater than this, the maximum stress. At a point, for instance, within the body, the stress is 75% of the maximum stress. Maximum stress is not over there, at a different part of the body. 75% of the maximum stress. If the stress at a point is equal to that much, then this is to say, okay, for this part also use a finer mesh. Of course, if you write 0 here, this means you're going to use finer mesh within the entire of the body. Then your computer may exhaust, may be exhausted, cannot use your computer. It is like, say, attempting to solve the problem analytically. Because this technique, it's a loop, we say that, okay, repeat the calculation, and for each repeat, decrease the mesh size, decrease the mesh size. If you write the refinement factor as, for instance, 100,000, etc., and infinitely large value, infinite number of times, repeat the solution. For each, decrease the mesh size, and in the limit, the mesh size is going to be practically infinitesimal small, 0. How many years needed? Infinite number of years. Can you use your computer? No, because it is not a supercomputer. Okay, well, I'm going to demonstrate the things for both of the cases. Well, if you select local mesh control option, then under your control, you can say that, yeah, okay, displays use such a mesh size. But if you enable the software to change the mesh size automatically, yes, use refinement facility, okay? But in the end, be aware, this percentage is important, and also the number of refinements, here it is 5. But of course, if we write a greater number, then the running time going to be greater. Okay then. To be able to have a discontinuity in this course, I am going to use this example. Well, there is a technical drawing where it is, I think. Yeah, yes, it is over here. Well, have a look at. You see, similar to the one, it is in the article published by that scientist how many years ago. And for this case, we have k-factor graph. Okay, it is also, well, I selected this example, also can make a verification, from theory, practical analysis, and also plus theoretical analysis. We know the k-factor, okay, to use for finding the maximum stress. We know the stress is going to be here and there if the loading is at this end, at that end. Okay, we are going to solve the problem using Inventor, tools of Inventor, and then when at home, have a look at using k-factor whether the stress value almost the same. Okay. Studying on this problem, I'm going to use local mesh control technique and also refinement technique, both of them. Okay, record the size of this object. It is the front view of the object. I am sure you know from technical drawing. If there is only one view, know that it is the front view. The width of the object 150, height of the object is 50, and the note says that thickness is 6. And the drill has been created at the center of the surface of this prism. Its diameter is 90. Okay, now first, define the work as a project. No, use the same project. Time is very limited, okay? But need to create the model of this object. Okay, in Inventor, let us create the model. You may close this file. We completed studying on this example. Okay. By the way, oh, very pity. I have forgotten to click on this button, and unfortunately in the record couldn't record the things. Okay, but at least for the rest, see the things. I talk about lots of things, but in the video record, the user will hear me only my voice, but not the projected things. Sorry for this. Okay, quickly bring the slides to the screen one more time. I said that, yes, my delivery is valid, but the ones I use those in supporting my talking. If there is a discontinuity, okay, within the body because of abrupt cross-sectional changing or existence of empty space, from the outputs of previous studies how many years ago held by engineering scientists using photoelastic methods, we know in the vicinity of discontinuity, stress value going to be much greater than the average stress value. The ratio between them is the stress concentration factor, and we have for such special cases already determined k factors, okay, given in the publication in the literature. It is available, and also this publication also subjected in strength of materials books, Okay, to be able to study on the example, yes, obey to the recommendation. If there is a discontinuity over there, to be able to find the calculation more accurately, I said use finer mesh. Okay, for having finer mesh, not the same mesh size, if there is no abrupt changing, no discontinuity, use greater mesh size to decrease the runtime, to be able to make the computer usable for such a solving. Well, to be able to use different mesh size at different places within the body, we have two techniques. One technique, well, in Inventor, we use local mesh control facility. The other technique, refinement method. Okay, well, enable the software to repeat the solution n times, but for each repetition say that use a smaller mesh size, where at the places stress is maximum, and also in this example 75% of the maximum stress or greater. Only such parts use finer mesh. Okay, and then to be able to study on both of the techniques, the example I selected is this one. Well, one more time, enable the others. They couldn't attend to this session. Yeah, that is the view of the object. Okay. Yes, create the model of the object and then deal with the stress analysis. Well, from the note, we know that the load is 2 kilonewtons and the material is, at the title block written, aluminum 6061. Okay, let us create the model. Open Inventor. Well, the active project, yeah, the same project is active, but the body is a new body. Clicked on New File Creation button. Well, this is first quadrant projection, so the values are in millimeters. Select metric unit system. Okay, part creation template. And then clicked on Create button. Solid model creation starts from sketching stage. Clicked on this and select one of the coordinate planes and then create a rectangle. Okay, arbitrarily it is, I remember 150 by 50. From here to there, the size is 150. If necessary, zoom out. The height is 50. Yes. 50, height is 50, thickness is 6. Okay. 19 is the drill diameter. Okay, finish the sketching stage. Apply the extrusion process. Thickness is 6 millimeters. Then say OK. That's the end of the valuable stage, so save the file. Or create the hole and then save the file. OK. Click on hole creation button. Start the process. It is not a standard hole, so don't click on this button. The automatically click one is toggled on is correct option. The diameter of the drill into this box, right, 19, and it is truly extending, so select this true all option. Such things from MEC 113. And then indicate the surface. Hole starts from where? It starts from here. And then the location dimensions relative to this edge of the surface. I know from the technical drawing, location dimension is 25. Relative to this boundary, location dimension from the technical drawing I know is 75. And then say OK. Yes. And then yes, it is made of aluminum. Assign the material and convert it to solid model. Clicked on this button. OK, find aluminum 6061. Right click the mouse, assign. Close the dialog box. And now save the file in the memory. Save as. The memory, we have the project folder, and since it is still active, we see the content of our project folder. Okay, write the name of the file, surname, ID number, and then say that part 2 or okay, part 2, date of today, March 23. That is the name of the file. When we run the software, then the folder will be created using this name, in which software keeps the data, log files. Okay, and then calculation time. Clicked on environment step. Well, I have already tested under the action of the load, material stays in elastic region, so no need to use Nasra. But whenever you see that it is going to be plastically deformed, then use Nasra. Okay. Clicked on this button and then, create study button, static analysis. Okay. Material shear assigned and recognized by the software. But just to say that for factor of safety, the threshold is yield limit. Yeah, yes, sure, yield limit. Say okay. At this end, the connection is fixed. No need to repeat the boundary load at this end, because program knows if at this end there is a load, at the other end we have the opposite directed force system. Its magnitude is equal to that of the other, because at the beginning we said that it is static. There is no net force, there is no acceleration, so don't waste time. At this end, say that there is a fixed connection, but do not repeat the loads in the opposite direction. It is unnecessary. I have already said such a thing first session, I remember. Okay, at this end we have fixed connection, apply. At the other end, well, here in the example distributed load, clicked on this button. The magnitude of the load is 2 kilonewtons. Okay, and that is the surface. It is not pushing but tension type load. Reverse the direction and then say okay. Mesh default setting the same, huh? Generate mesh. Default setting broke 276 finite elements. But we know from the outcome of mechanics of materials, and also today, few minutes, I made a brief review that it is so. Well, this hole is a discontinuity, and if the load is in this sense, then here and there, just very close region to the hole, stress will be in the maximum order. Since the maximum stress is important and the maximum value is to be calculated more accurately, okay, instead of using such a coarse mesh, use finer mesh. But in doing this, I'm going to enable the software to set the mesh size at the background. Step by step, decrease the size of the mesh where in the vicinity of the maximum stress values, and the ones at the places, if I say that 70% of maximum stress, then also the parts, the stress at the end of the first running, program will say that this is the maximum stress, and the other points, the stress is 75% of the maximum or greater than 75%. At such places, Inventor decrease the mesh size. It's going to be automatic. For that purpose, yes, clicked on this button, okay, convergence setting button. And then, how many times gonna allow the software to repeat the running, via which making this corresponding to decreasing the mesh size. Let's say 5 times, 6 times. But if I write greater than 5, program friendly notify me, be aware, running time may be too much. But I think 5, 6, okay, just to say that, why not, can write a greater number than 5. Let us write 6. Okay, stop criteria, although, well, the available default value is 10%, say that not 10%, but 5%. for having the results more accurately. Threshold value is 75%. It is to say, if the stress at a point is 75% of the maximum one, then over there as well, use a finer mesh. And then say OK. Yes, friendly notice. Inventor says that specified number of refinement, it is greater than 5, larger than 5, so it may cause to great runtime. Continue, yes, yeah, continue. But if it were 20, 30, then yes, say continue and then wait in the order of hours. Yeah, be aware. And then, okay, here it is written, well, mesh view, generate mesh. Mesh view, mesh setting. Bring the cursor onto mesh icon, right click the mouse, and then yes, okay, well, we start from this coarse meshing. The mesh going to be refined while the problem is being solved. Okay, so clicked on run button. And then now at the background, repeated the solution, and then yes, here is the result. The maximum stress as it is expected in the vicinity of the discontinuity, here and there. How much it is? 24.5 megapascal. And then it is important whether, since we said that repeat the calculation for each decreasing the mesh size, you see Inventor, you see, well, at the places only where the stress maximum or 75% or greater than decrease the mesh size. You see here in the vicinity of these parts we have smaller finite elements. The rest coarse elements, bigger size. Yes, Inventor did it automatically. Well, it is still the question. Yeah, we said that 6 times repeat the calculation, decreasing the mesh size in the vicinity of those. Whether the curve reached to, say, asymptotically, of course, convergence. Well, have a look at the graph, convergence graph. Yeah, yes, you see that is okay. First running, the stress was 9 megapascal, and then increased the second repetition, well, closer to 20 megapascal. This is the answer. Yeah, hocam, how many finite elements need to use for finding the solution more accurately? If you use few finite elements, then you may find the result 16 megapascal. It is misleading. Increase the mesh number, increase the finite element, and then repeat the calculation. Third repetition, you see not 9 megapascal, but say 24 megapascal. But after the fourth running, the difference between the result of the fourth running and the next running is negligible, because the curve you see converging. No need to repeat the calculation, but it is, you see, almost the same. It is okay. If you say, no, hocam, I am keen on repeating the running, furtherly decreasing the mesh size, okay, right, not 6, but 10. Okay, but this is okay. You see, I see that curve has been converged. Okay, then that is it. Refinement technique is this one. Finish the analysis. The other things, of course, well, as you learned already, factor of safety, displacement value, etc. 25.4 megapascal. If you want, then, well, you may check, but not right now. At home, you may check K factor, using K factor. Yes, where is the graph? Graph is over here. Yes, first D over D, D19, okay, divided by 50 is the geometric factor, okay, calculated, and from the graph read the K factor, And then at the cross section, this is the critical cross section. Find the stress value using atomic bonding forces, since it is in equilibrium, must be equal to 2 kilonewtons, divided by the cross-sectional area, and then multiply the result by the K factor. And then you can check whether the result is equal to that much, 25 megapascal. I am sure it is very near to that number. At home you may check it. Okay, finish this analysis and then clicked on environment step. Well, without forgetting save, clicked on save button. It may be the case, while previous hour, 2 students unfortunately found the computer as completely blocked. Couldn't click on any button, so shut down the computer. So if you forgot to save the file, then need to repeat the calculation. So repeated to save the file. Okay, I saved the file. I am sure at the background a new folder has just been created. Okay, in the folder we have the results of this calculation. Okay, the other facility, the other technique for having finer mesh, clicked on the button again. And then yes, it is going to be a new studying. Clicked on one more time, clicked on this. It is going to be the second stress analysis. Okay. Now the previous one is inactive. The newly defined one is active. Quickly do the same things. Boundary condition. Okay, 2 kilonewtons at this end. It is tension type loading. Okay, the other end fixed connected. And then mesh. This is the default mesh. But I know from the theory or learning outcome gathered in engineering faculty, taking the course mechanics of materials, etc., or my delivery of today, we know, well, this is a discontinuity, and in the vicinity of this one, to be able to find the stress values more accurately, use a smaller mesh. Well, the other facility is that, yeah, well, here is the button, local mesh control. Clicked on this, and then in the dialog box, mesh size. In the vicinity of the hole, I'm going to use 1 millimeter as the average mesh size. Okay, say that 1 millimeter is the mesh size. Where indicate the surface. And then say OK. Then yes, since I use local mesh control facility, well, Inventor wrote thunderstrike symbol next to mesh icon and says that the existing mesh is not valid. Updated. Yes, bring the cursor onto this icon, right click the mouse, and then find update mesh option. With a click, do it. And then yes, you see, it is a new mesh, and in the vicinity of the indicated discontinuity, we have smaller elements. Smaller elements means more accurate solution, yes. No, not surface. Then if there were a sharp edge, then I would say that indicate the sharp edge. Okay? Or even, for instance, if you want to use finer mesh, indicate this edge, indicate the surface. Well, to increase the accuracy, use finer mesh. Where? If there is a discontinuity or abrupt changing, as I said. In this example, I said 1 millimeter. If you want, decrease the mesh size 0.5. But smaller mesh size, greater runtime, and also more powerful computer. Yeah, well, if you indicate the edge, that is going to be wrong because the feature extends from here to there. It is a whole. In the vicinity of the edge, inventor use finer mesh, not the rest. Here, if it is a surface, and in the vicinity of the surface need to find the solution more accurately, indicate the surface, not the edge. Okay? I indicated the surface. I broke the cursor, not here, not there, but to the surface, and indicated. So, well, at both of the sides, throughout the whole, you see the finite elements, you see, in smaller size. If you indicated the edge only, then in the vicinity of the edge only, we will find the elements as smaller in size. Okay, yeah, this is the other technique. And then the rest solve the problem. And then you see the result almost the same, 25.5 megapascal. And the highlighted places, yes, are expected in the vicinity of the discontinuity, the stress is maximum. Yes, that is okay, I think, huh? Finer mesh, how you can control the mesh size. These are the alternative techniques. Under your control, for different discontinuities, you may use different mesh size. Then, if it is the case, then select local mesh control technique. But if you allow the software to generate smaller mesh, smaller elements, where in the vicinity of the places the stress is going to be maximum or near to maximum value, use refinement technique, this facility. Okay, yes, completed the things within the scope of this short course related with the tools of Inventor. Save the file one more time. And then repeat again. If you're going to send the data for the interest of the other person in professional life, your colleague, the interest of the other company, etc., then don't forget, zip the project folder. Okay? If it were an assembly, then I would say that apply pack and go process. Don't forget to apply pack and go process. If you forgot applying the pack and go process, then the other person can open the solid model file, but cannot find the models of some components and also the geometrical constraints for the components. Well, in short, can say that there will be a serious difficulty at the side of the other person. Well, Inventor will ask lots of questions. Where is this file? Where is this file? How many files? In the order of few hundred files. But pack and go process, gather all the files, okay, collect them where into the destination folder. Within the destination folder, it is to keep in the project folder. So that's why all the things going to be in the project folder. Zip it, and then you can send it. But not right now. Say, just I reminded, first week, first session, you know, I kindly requested you to zip the folder and already collected the data. Today, who knows, at 10th, I may request you to do the same thing. But here, okay, now, focus the attention to fusion. Mechanical engineering students already made an introduction, I know, in Introduction to Mechanical Engineering course, Mech 100. While using few hours, I did it. I do such a thing, make an introduction to fusion. Here, I know that the participants are from different departments, different programs. So I'll quickly repeat the introducing part, or for the first time, talk about some introductory things. I may close Inventor if the computer is not so good, classroom is not so powerful. Do not keep the software, okay, unnecessarily as active. Close them. Okay. And then, yes, Fusion. Okay, bring the cursor into the search box. If it is classroom computer at the desktop, you can find program shortcuts folder. Okay, open the folder and find the up-to-date version of Fusion. From the date, you can see which one is up-to-date. There are two alternative options. Okay, for one of them, the up-to-dating time is new. Well, or into the search box, write the name of the software, Fusion, and then in the list you can see the hyperlink to click. In opening Fusion, you cannot find the version. If it were Inventor, we would find 2024, for instance. Fusion is very up-to-date. Autodesk updates the software periodically, each 2 weeks, normally. It is like open source software. Lots of scientists, academicians, users, students continuously use Fusion today. It is quite popular software today and getting more popular. So users continuously feedback, say that there is a problem here, there is an insufficiency there. So the experts, coders of Autodesk, engineers of Autodesk, considering the feedback, update the software. Well, if it is for the first time, the attempt is for the first time, and your session is not active yet then when you select the software, making a click onto its name, then Autodesk will bring login dialog and ask you to write your username in filling the form for being in the end the member of student association, student committee of Autodesk. You selected the username and also Autodesk password. Yes, need to write your username and then after the next button, clicking on the next button, write your Autodesk password. Well, I didn't pass through such a login stage because, I didn't log out from Fusion environment. Yesterday, one more time we used Fusion, okay, in one of the courses, and obey to my recommendation. Well, this is my avatar. Clicked on this. If you're going to end your session, clicked on sign out button. But if the computer is your computer, I do not recommend. Without signing out, close Fusion. Then whenever you need to open Fusion again, just click on its name. It is an hyperlink. Then Autodesk, without asking you to write your username, etc., will bring the things in your account. Well, this is my account. Be aware, Fusion is a class-based software. Well, in the classroom computers or your computer, when you select Fusion and install the program, be aware that it won't be the main program. The main program as a whole is in the memory of the host computer of Autodesk. It is in the United States. The installed program is just a module. Having such a module can connect your computer to the host computer of Autodesk. When you create something and clicked on Save button, sure, it is going to be saved, not in your computer, in your account, where it is in the host computer of Autodesk. Since it is so, it is said, if you are studying, if it is project is top secret project, don't use Fusion, because your project first recorded in the United States. Okay, be aware. If your product is an ordinary product, well, it's not so important. What is that? It's a piston, it's a refrigerator, it is a table, armchair. Then United States will not be interested with such an ordinary product, and you may use Fusion. But it is military purpose, and it is, for the first time, completely secret, then don't use Fusion. Okay, how you can create a new folder? Well, in this pane, by the way, clicking on this button, you can hide it, and via which have greater space in the screen. Clicking on this one, you can have this this pane. If you already created some folders, okay, to group the data, yeah, you can see the list. Well, in your account, I know here it is written new project. Clicked on new project button, and after clicking on new project, of course, name the project with a special name. For instance, you may say Subtech course, etc. And then can find thereafter new folder button. Okay. It is a good practice to keep the data within different folders. I'm going to create a new folder. And then, well, let me know. I talked about or studied on such things in the scope of this course. I'm going to say surname, the name of the folder, ID number, and then say that Subtech course. It is a good practice. Then likely history of the studying. Okay, and also, well, we studied on such things at which time. Write the date of today, dash, let's say March 23, which date, which year, this year, 2024. Who knows, society may kindly request me to repeat the course next year, then I may write at that time, date of that year. Okay, and then open this folder with a double click. And then, well, this pane is the working area. Okay, it is very similar to Inventor. Well, model. Let us create the solid model of the object. It is going to be the first example, rectangular prism, 50 by 100 cross section, 1500 is the length. Sketch button is over here. Clicked on the button and then select one of the coordinate planes for the first sketch. This, or that. Cartesian coordinate system is defined in the environment of Fusion. Okay, I am going to select this one. Okay, this dot is at the origin of the coordinate system. We know that the cross section is a rectangle. So created a rectangle. If you arbitrarily created, then okay, then use dimensional constraints, or let me say, oops, undo. Well, first corner, and then you see we have boxes. This box is active. Instead of using dimensional constraint, if you want, just at the creation stage, you can input the values. 100, clicked on tab, take a right for writing the other numbers, 50. Or if you skip that typing stage, then I say, well, drop this list and then find sketch dimension option. This is dimensional constraint facility. Clicked on this and input the dimensional constraints. Okay, the sketch is okay. Finish the sketching stage. Clicking on finish sketch button, and then the rest, extrusion. We know it's a right prism. Into this box, write the length of the prism, 1500. And then in the dialog box, extrusion dialog box, it is a common question. Yeah, hocam, there is a list here. Shall we select new body or new component? Well, the recommended one is, if you know that object is an assembly and this is one of the components, select new component option. Well, new component will include new body within its definition. Advantage of defining the object as a new component, well, we can find origin folder, okay, special for that component. Not only one origin folder, but for each new component can have correspondingly original folders. Some cases, to be able to position one component with respect to other, we use the coordinate planes as reference. For each component, if you have associatively coordinate planes, then you can use the coordinate plane of this, coordinate plane of the other, and then can say that the coordinate planes are parallel. Coordinate planes are perpendicular. Using the coordinate planes can position the components with respect to each other. But in the content of this course, there is no studying about assemblies. So just only deliver such sentence, hoping that you understood what I mean. So obey to the recommendation and select component option. And then say OK. Yes, our prism. And then assign the material. How? Modify. Click on this listing arrow. And in the list, find physical material option. That is the browser. Select metal option. And then scroll. It is made of ASTM A36, you know. Scroll, find the group. It says ASTM, steel ASTM. Yeah, 36, I found it. And in Inventor, you know, for assigning the material, right-click the mouse while the cursor is on the name of the material option, and then assign. But in using Fusion, with the left click, hold the material, and move the mouse, drag the mouse toward the object. At any point, okay, when you reach to a certain point in the vicinity of the model, remove your finger from the left button of the mouse. That is the thing to do in the procedure for assigning the material. Okay, then close this dialog box. No need to keep it. Okay, that is the model creation stage. Actually, in Fusion, well, there is a listing arrow in its environment. By the way, dear students, I forgot dear participants. Yes. Yeah, well, I dropped this list in modified panel, clicking on the title of the panel, and then found physical materials option, clicked on it, and then the dialog box has just appeared in the screen. I found the material and then hold the material option, dragging the mouse, move the cursor toward the body, and then release the finger, release the left button. Yeah, well, already know that material is ASTM A36. In the example, you know, the material has been given as ASTM. Well, which problem we already selected for verification purpose and study it. Remind you why I selected that material. Yes, here it is written in the example, material is A36. Yeah, object is the same object and the magnitude of the force 80 kilonewton. Since time is flying and need to complete the studying in few minutes, well, say that, okay, after learning how it is done, well, solve this problem. Okay, then solve both of them, 80 kilonewtons, and then say that point force, how the point force is defined in Fusion. Already answered this question for Nasran, but in Fusion it is not the same. Okay, it is a little bit tricky. So, okay, assign the material, close this dialog box. In Fusion, clicked on this listing. If you open Fusion, well, the file, it is in default name, untitled, not saved yet. Well, Fusion automatically selects from this list design option. If the option is design option, this means it is the model creation environment. And the thing to do is that create the model. Okay, model creation is okay. Save the file in the memory. Clicked on save button. Write the name of the file, surname, ID number, and then say that subtext, part 2, part 3, I think, part 3, subtext. Date of today, March 23. Okay, which folder is the location? Already selected the specific, specially created folder, but of course you can change the address if you decided or gave up. Drop the list of the existing folders and then select it. But here already the selected folder is the correct address, subtext folder. And then the rest, clicked on save button. And it is not in the memory of the computer. We save it in the host computer of the company. Okay. And then the calculation stage. Clicked on this listing arrow. And then you see in the list what we have. Rendering, generative design, animation, simulation, manufacturing. Yeah, Fusion. Using Fusion, we can generate digital codes to send to CNCs, 3D printers, robot hands. Yeah, manufacturing is not included to this short course. Animation in MEC 114 and also in the content of ASE 9492 course, it is one of the chapters, animation file. If you prepare an animation file, then can see the components flying in the atmosphere and finding their places within the structure of the assembly. It may be a useful animation file. But if you select simulation option, then Fusion can understand that it is the calculation time. By the way, dear students, I forgot to notify you at the beginning. Well, configure Fusion. How? Find the avatar, Murat Sönmez. After logging, you can find your name in your account here. Click on this button and then you see it is written preference. Select preference option. And in the dialog box, well, from this first pane, well, for having a look at the default configuration of Fusion, and if necessary to change some of them, well, try. For instance, units and values display. I selected this one, and then general precision. Well, scientific notation. Minimum precision when hiding tracing zeros, trailing zeros. Well, material of unit display. Drop this, and shall you see the things in British unit or metric unit? I selected metric standards. I want to see the values in megapascal. Okay, mass kilogram, energy joule. Yeah, this is an important stage. Select the suitable unit system, and then where the other default units for the design, yeah, millimeter, you know, in engineering drawing we use millimeter. If you want, of course, you can select inch, foot, centimeter, etc., etc. Well, there is such a configuration stage. Be aware. And then, yes, the time to calculate. Drop this list and select simulation option. After clicking on simulation button, you can see this dialog box and then see the power of Fusion. Well, in the table we have which option? Static stress analysis, yes, Fusion capable. Model frequency analysis, Fusion can output the resonance frequencies for the structure and then can say something whether, for instance, during earthquake, there will be resonance. Okay, whether your product will start to resonate, or say that your structure is to support an electrical motor, or it is the structure of the aircraft, okay, while the jet engine rotating with unfortunately some undesirable centrifugal forces, that running will start to shake the structure. if the frequency of the rotation is equal to the natural frequency of the structure, then structure will resonate. The amplitude of the oscillations theoretically will be infinitely large. Of course, material cannot resist to, and then the result will be failure. Yes. Yeah, yes. Not not electrical, of course. Saying resonance frequency, I do not mean say three-phase electrical current, 50 hertz, 60 hertz. No, but this is different. Mechanical vibration. Okay. Yes. How can I say? Yeah, yes. Simply clicked on save button. Okay. If you have already saved but couldn't perceive that you completed the stage, then this button will be in light tone. Fusion knows that, yeah, you have already saved while you're clicking. You can click but cannot have the save dialog box. I clicked on this, but you see couldn't find the, clicked on this, you see it is inactive because Fusion knows that I have already saved. But of course, if you're going to save the file with a different name, second saving, then from this list, select Save As option. That is okay. But if you select Save As option, then Fusion expects to find a different file name. Okay, I clicked on Save button, and in the dialog box, wrote the name of the file saying blah blah blah. Well, already created a new project, and thereafter a new folder, clicking on new folder, and then double clicking selected that folder and said that it is the address for this project. Okay, Fusion knows that the folder is blah blah Savtech folder. Okay, I didn't change the folder. Okay, and then, well, turn back to here. If you select simulation option, then yes, first see this table and can conclude that Fusion is the software that can be used for static stress analysis, module analysis, heat transfer phenomena, thermal stress, backlink, nonlinear static, nonlinear plastic deformation, okay, impact mechanics, and shape optimization is also possible. Sustainable solution is offered by Fusion as well. Okay, now in our case it is static stress. Select this option and then click on Create Study button. And then, well, no need to keep this pane. Have a greater space. Clicked on this, toggle of it. This is the browser, similar to that of Inventor. We have mesh icon, but there is no mesh yet. We have results icon, but there is no results yet. Okay. Well, first clicked on materials button. And then check whether along the row the material is written. Since we have already taught the software that is made of steel, now it is over there. If not, then we will click on materials tab, drop this list, and then select Fusion Material Library, and then indicate the material. And also, well, similarly, yield strength. What is the definition for factor of safety? Shall you use yield limit or tensile strength? If plastic deformation is not allowed, then use yield strength. Okay. Close this dialog box. Constraints, yes. Clicked on this structural constraint. Select structural constraint. Well, at this end, you know the problem. The connection is fixed. Okay, there is no freedom in any direction. Okay. And at the other end, for the first problem, the load is 80 kilonewtons, and it is uniformly distributed. Okay, clicked on loads button, and then which kind of load? Force, pressure, moment, bearing load, remote force, hydrostatic pressure, remote moment. Okay, say that force in our case. Select the surface, indicate the surface. This is the surface. After indicating the surface, yes, the dialog box expanded. And well, if you know the Cartesian coordinates because the load is oblique or inclined, select this option. Then can find the X, Y, Z boxes to write the components. If you know that the load is normally directed to the surface, then this is the correct option. Well, similar to Inventor, we have flip-flop facility. Well, this is compression type loading, but we know that it is tension, flip-flop direction. And the magnitude of the force, 80 kilonewtons. Okay. And then say okay. Well, similar to the classical path of Inventor, Fusion brings only one arrow. But whenever it is your WR, whether it is point force or distributed force, move the cursor to the vicinity of the arrow, then Fusion highlights, bringing more arrows that it is a distributed load. Okay, but in Fusion can find a refinement facility, local mesh facility. Well, at home you may be interested with such further details, but since time is really very limited and in 5 or maximum 10 minutes need to end the session, I'm going to use the default mesh configuration. Okay, but at home you may use the finer mesh facilities. Okay, boundary conditions are okay, and then mesh. Well, here we have manage option, and over there, yes, indicate the address. If you're going to use finer mesh at some parts, local mesh control facilities over there. Okay, but I'm not going to use local mesh control. And well, here in Sol panel, you see we have two options. First, generate mesh, and then click on Sol button. Generate mesh. For alternative address, bring the cursor to the browser. Over there, it is written mesh. Right-click the mouse and select generate mesh. How you can change the mesh size? There is a pencil point here. Click on this, and then the dialog box appears. Similar to Inventor, well, Fusion automatically selects fraction option and say that present setting 10% of the overall size is the average mesh size. Sweeping this bar, you can decrease the size of finite elements. Or if you want, you may select absolute size option, and instead of writing percentage, using percentage, you can numerically fix the element size, 10 millimeters, 5 millimeters, etc. Be aware. This is the thing to do for changing the mesh size for the entire of the body. It is not local mesh, okay? For that, new mesh setting will be applicable for all the points throughout the body. Okay, generate the mesh. Default mesh. Okay. And then solve the problem. Find solve option, click. Now this is the dialog box. The problem will be sent to host computer. Okay, well, at this point, be aware there will be a queue. Your work will be in the queue. Depending on the internet traffic and internet speed between your country and the United States, then well, and also at present, for instance, right now, if it is the prime time in the United States and also some European countries, lots of scientists, academicians, engineers sending lots of problems to the host computer. The queue may be very long queue, okay? Traffic very crowded, so while the waiting time may be in the order of not seconds, not minutes, even hours. So if it is too much for you, then say that while the others sleeping, then wake up and then study on your problem. At that time, traffic won't be so crowded. Okay, now here send the problem, clicking on solve study. to the host computer. Now, it is in the queue and wait. Yeah, well, I see 100% of the problem received over there in the host computer, but the solution 10% of the problem processed right now. Wait. Yeah, yes, your friend says that, oh, hocam, my problem has already been solved. But I'm going to use my screen, hoping that in few seconds I'm going to find the good news. Well, sending stage completed, but the process, 30% of the process has already been executed. Yeah, the main reason, the traffic, the other one, internet connection. Now, you know, TRNC has only one cable connection between this country and Turkey. Fiber optic cable is across the Mediterranean Sea. Yeah, sending is okay, but processing is for calculation. Okay? It says solving 6% of the solution has already been done. But computer is, well, okay, but that supercomputer solving how many problems at present? It is not the only problem. The number of problems may be in the order of even million. Okay? Lots of people today use Fusion. Okay, then finally completed the solution. Well, in Fusion, dear students, well, there is a blue button here and correspondingly double arrow there. If you clicked on it, you can see the recommendation of the software. Software saying that, yeah, factor of safety is 15. It says, use shape optimization facility of the software to remove unnecessary material. Find the optimum solution, sustainable solution. Or Fusion says that try testing another material. Why you selected this strong material if the load is in this order? Use a weaker material if it is cheaper, of course. Or while using generative design facility, then find a different geometry for this product. A valuable recommendation. And then, well, here we have such a scale. The selected one is factor of safety. I wonder stress distribution. Drop this list and select stress. And then, yes, the maximum stress, the same, 17 megapascal. Well, similarly here can find a probe. Okay, inspection panel. Well, there is a probe facility, point probe, and then bring the cursor here. Yeah, yes, you see it is 16 megapascal. But the maximum stress is in the vicinity of this rigid connection. So on and so forth. Well, similarly, well, you see right now the deformation in the maximum zoom in order. But if you want to see the actual deformation from this list, select actual. Well, for this load, if the material is such a strong material, the deformation is not so distinguishable because it is 0.1 millimeter. The other things are quite similar. You can create a video film, okay, to allow the others to see the deformation while the load is being gradually applied, etc., etc. Okay, you may try the other things. Okay, we completed the studying and then, well, clicked on finish results, and then second studying, it is going to be a point force. Okay, point force. So clicked on this button, and then for the same body, perform the analysis with a different boundary condition. Static stress again. Clicked on create button. Now the previous analysis is inactive. Then the new one is ready for our definitions. Okay. one end of the body is fixedly connected, constraint, structural constraint, that is the surface fixedly connected. The other end. Now at the other end we have a point force, practically point force. Now see, how can define the load as almost a point force? In Inventor I said that using work plane split the surface. But in Fusion it is not the method. See how. First, as if it were over the entire of the surface, define the load, structural load, indicate the surface, okay, flip-flop the direction. Now already tested, if we apply 80 kilonewton at a point, then there will be plastic deformations, even it may completely be broken in the vicinity of such a point. So, well, previous example we said 3 kilonewtons point force, do you remember? 2 kilonewtons. No. 9 kilonewtons. No, it was for bending. Well, for tension purpose, I remember I said 3 kilonewtons. Okay, write 3000 or 3 kilonewtons, 3000 newtons, capital N. At present it is distributed, uniformly distributed, but after clicking on this intermediate button, see, now the dialog box is greater in size. And after having the dialog box as expanded, then find limit target option, clicked on this, and then over the surface can find the gripping button, hold it, and then hold this button. And then you see, over the surface it is possible to define a circle. Yes, make the circle smaller, 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 dynamically moving the cursor toward the center. Okay? While you're making such a size setting, within this box you can numerically monitor the changing values. Well, the size of the contact area is, let's say, 6 millimeters. We said 6. Okay, 6 millimeters. Now you see here, over the surface, we have such an area, 6 millimeters. I'm going to indicate this area as the contact surface. If the contact point is not here, at present it is at the centroid of the surface, but here or there, then see how it is moved to the new location. Well, dynamically hold the center, okay, and then move the point of application from here to there. But if you need to numerically locate it at a certain specified place, then indicate this reference, indicate this boundary, for instance, as reference, and into the box write the location dimension of the center of the contact surface. Well, in this example, let us have the contact surface at the center of the main surface. So the coordinate is 25. Relative to this edge, indicate this edge with a click. The other coordinate is half of 150. So it is at the center of the surface. While the contact area is very little, 6 millimeters is the radius. It is radius, not diameter. Say that radius is 3 millimeters. Diameter is 6 millimeters. Okay, that is the answer. Yeah, how can have a point force? Yeah, using this technique, we can make the contact area smaller, 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 and numerically fix it. And then say okay. Yes, now Fusion learned that it is a force, load, okay, it is acting over this surface, tiny surface. Okay, then run this problem, use not finer mesh, default value has not been computed, yes, computed, generate mesh, and then, well, solve the problem. Find solve. Again, send the data to the United States. Yes, 30% of the work has already been achieved. Waiting. One percent of the solution is achieved, has achieved. Yes, well, at home, yes, thanks to such an introduction, I am sure can study on bending type loading, huh? And after seeing that, yeah, there will be plastic deformation, select, well, the nonlinear option from the table, and then, well, deal with the rest. Okay, short course, only, well, at that level. But I think that is true. You agree with me that you learned valuable things, right? Although it is a short course, but well, I think well that is okay, and managed to open the gate. The rest depends your interest and your further study, dear students. Well, I'm keen on seeing the results, and then say that completed the course, and then can well both of them powerful. Well, no, well, the advantage of fusion, for some problems, it is more user friendly. Okay, in Nasran, there are some tricks, well, very tricky tricks. Okay, well, you should know them, but using fusion is easier relatively. For instance, in using Nasran, using work plans, we split the area, but here it is much easier. Uh, well, the economical side, it is a cheaper software. Okay, for instance, Inventor, if it is the new version of Inventor, in today's currency, I think per license in the market, you should pay 30,000 Turkish lira. 25, 30,000, the order is in this order. But to be able to take a right to use Fusion per year, pay 900 US dollar. It is cheaper. The disadvantage of Fusion is that Big Boss will monitor your study. Okay? Yeah, yes, later. But here, okay, solution is okay, but there is still something which is extremely important. Well, saying by the way. Okay, first have a look at the solution. Yes, factor of safety, stress value, maximum stress, okay, etc. Okay, then well, solution is okay, let's say. Well, what about this? Finish the analysis, and then, yeah, well, the data is in the host computer. Save the file one more time. But you need to have the solid model in your personal computer. And also, well, this is your account. The others cannot access your account because you have a password. And if you inform the teacher on your password, then yours. Yes, your teacher can check your solution. But if it is not so convenient for you, you don't want to share your password, then be aware in using Fusion. That is the thing to do. Well, click on this listing arrow and find over there share option, share file link. Make a click on it, and this dialog box will appear. In the dialog box, click on this button, and then Fusion will generate an address, link. Okay, copy the link, and then send this link to the other person, writing an email message. And then the rest, assume, well, I received the email message, and then open a web browser, no need to have Fusion, okay? The person has no right to use Fusion. No problem, that person can use web browser. This is Google. Right click and paste the link, and then press enter. Then yes, in web environment, the person or yourself can find the model of the object, and then can find some facilities, measurement facility, orbit facility, etc. Along the bar at the bottom edge. And then the valuable thing to know, downloading facility. Well, you may download the file to your computer in Fusion format, in Inventor format, SAT format, STEP format, STL format. STL is the common format that is used almost in all 3D printers. SAT or STEP is the common format, are the common formats. We use we have the solid models in such format for studying on external fluid flow, CFD analysis. Be aware, for instance, now I'm going to download the file in Inventor format or SAT format. Okay, Inventor format. I selected Inventor option. Now, company says that, okay, write the email address of that person. Well, my email address, I wrote. It is to say that that is the email address. Well, company asks the email address to allow that person to complete the downloading, and also it is for verification purpose, whether the person is an eligible person. Okay, I said send. Clicked on send. Yes, company says that that person will receive an email message, blah, blah. Okay, follow me. And then after the course meeting, then you can ask your questions. So sorry. I'm a little bit in panic. Well, I have only 4 minutes to complete the course. I'm sorry. Okay, and then email address. Well, open your mail account. And then, well, still waiting to receive that mail. Yes, here it is. Well, I have just received the mail sent by the system. It says download. Yes, after opening the mail and clicking on download button, you can download your creation or the creation of that person where in downloads folder. Here it is. And then cut, paste to Session-2nd folder, etc. I'm going to do it quickly. Right click, cut, and then I'm going to paste in the folder of this course, Session-2nd folder. Okay. Right click, paste. Here is the downloaded file. It is in compressed format. Extract here. And here is the file. It is in Inventor format. It might be SAT format if I selected SAT. The other thing, well, turn back to web browser. How about the results of the calculation? Well, clicked on simulation button. And then, well, we repeated the simulation twice. So, well, this is the last one, I think. Okay, want to see the first or the second. Select the option. And then, yes. In the screen, you can see the results. Factor of safety. No stress distribution. Yeah. This is not Fusion. It is still web environment, but, well, the person can see, he or she may be your teacher or your colleague, okay, can see the results. Okay, also in Fusion can find report button, clicked on report button and then download the calculations numerically available on the sheet. These are all possible. Okay, dear participants, well, ending this short course, and also, well, without forgetting stop recording, one more time, allow the others to see my face. Murat Hoca, yes. Thank you for your interest and patience. Okay, that's all in the content of this short course. And one more time, deliver my thanks to the society. Okay, society, student society, especially Defense Technology Society, enable me to offer such a course for the benefit of my dear students, dear participants. Thank you so much. That's all.